Hello everybody, I'm Walt McCarthy. Today we will be reviewing corrosion protection for underground steel structures. This is an underground steel structure, X shape. Anytime you put a steel entity, structure, underground, you're going to have a negative charge at the bottom, and you're going to have a positive charge at the top. That's the cathodic area. That's just the way steel works. That's the way steel corrodes. But if you put an anode on it, which is negative, and it's more negative, then it's got a higher potential, and you put an anode there, then as the current, the electrical current, corrosion is steel corrosion on the ground is an electrical process. As the electrical process starts and comes out, it will erode this anode instead of the steel structure. So if you want to keep the pressure rating of the shelter, 15 psi, 20 psi, whatever the design pressure is, if you want to keep that for the next 30 or 50 years, you have to have some type of anode on here, and it has to be done right. I usually put them out here on the ground because they work a lot better. This is what a packaged anode looks like. Inside this bag is a magnesium bar, and it's packaged usually with gypsum all the way around it, some type of powder all the way around it, and that has a wire connected to it here, and that's what you put in the ground. When you put it in the ground, you put some water on it to start it activating, and that goes on the bottom of the shelter and connects electrically up to the top of the shelter. So this is how it's usually set up. You've got an anode 2-3 feet away from the bottom of the shelter. Electrical wire comes up to the top, which is the positive side. This becomes negative. So when the electrical process goes around, it's going to come out of this anode and erode that anode instead of the steel. Now, one of the tricks here, one of the things you have to do if you're going to use this, it works well. But you've got to sandblast the steel to a white blast, and you have to put a coating on it that's a dielectric coating, and that dielectric coating has to go on everywhere. Here you usually have a gasket, so you need a separate anode for this. You can't use these anodes to protect this entranceway, so we have a separate anode for this. Now these anodes, you can size these for 20 years, 30 years, 50 years, or 100 years. But at their service life, you have to be able to dig down. If it's 50 years, in 50 years, you got to dig down and replace that. So you can maintain the pressure rating of the shelter only for a steel shelter, only if you have cathodic protection on it. If you've got a dielectric coating on it as a paint coating, and you've sandblasted it to a white blast. So this works well. I've had shelters in the ground now for over 40 years, and they have the same dimension across here. When I put a gauge, an electronic gauge up to it, they haven't lost even a thousandth of an inch of their wall thickness. So the 50-year anodes are working. Up here, because we have a pipe flange here and a neoprene gasket, this is going to be isolated then. So you have to have another anode that's on the other side here, that's actually connected to an ear on here, so this is protected. Just remember, a lot of people ask me why we don't do stainless steel underground, and then you wouldn't have to do this, but it doesn't work that way. Stainless steel is good in corrosion in an aerobic environment where there's air. Where it's underground, it's anaerobic. There's no air. It doesn't do even as well as carbon steel. It corrodes it actually faster. So that's why you never see underground tanks out of stainless steel. This is a carbon steel structure that was sandblasted and painted with a dielectric coating. And this has also got a gravity flange on here on both ends. So this is the sort of thing that you want. There's ears on top. You can't see it here, but there's ears on top. The anodes would go down here. They'd be coming up top. This is one continuous electrical connected section here. So we put anodes around here, and that shields this whole thing. So this was designed for a 50-year service life. That's what the contract required, and we can meet that with a 50-year anode and electrically properly connected to the shelter.